Are you having problems, Fraser?
Yes. Hold on. You should be able to unmute your video, I think. You might have to reload if that's not going to work.
Yeah, I think there it goes. Okay.
Okay, good.
I loved the moment when you tried sharing my screen with the world. I really appreciate that.
Yeah, no problem. I new technology and all. I'm a bit of a Luddite. I don't like technology. I don't understand
Hi,
it.
world.
Hello, Pamela.
Hi, Fraser.
All right. Hey, episode 360. How cool is that?
We've achieved a number that sounds like it should be a perfect square and is not.
We're such squares. And then we're close to 365, which is the name of the other podcast
Yeah.
that we do. So there you go. All right. Well, this is, I'm sure, just really gripping stuff for people. So before we get on with the actual show, a couple of things. You are watching a live recording of the Astronomy Cast podcast. So we're going to take about half an hour, record today's show, which is on Jocelyn Bell Burnell, which is what we were supposed to be doing last week, but then things got switched around, and so today it's Jocelyn Bell Burnell, discoverer of pulsars.
And we were
And
supposed to be doing it 2 weeks ago, which is the week we didn't record.
let's just go with my story. That's even more complicated. It was how there was Thanksgiving anyway. So so we're gonna record the show, and then we'll stick around and answer your questions about space and astronomy. In other news, on Wednesday at 1 p.m. Pacific, 4 p.m. Eastern, I'm going to be doing a live hangout with the science team from NASA's New Horizons spacecraft. It's going to be on this channel. So it's going to be Alan Stern and 5 postdocs, which we're calling, it's his new band, Alan Stern and the Postdocs. So we're going to be talking about, I don't know if people know, New Horizons just woke up. We're about 7 months, 8 months away from it reaching Pluto, and we wanted to kind of give everybody the big update. So you should be able to see that on my channel. You can go to Universe Today. There's a link there. I've posted it on Twitter. I know they're hard to find, these events. Universe Today is probably the best place, and then there'll be a link there on the story. And that'll be on Wednesday at 1 p.m. Pacific time. All right. Let's get going with the show. Do you have any more announcements?
Not that I can think of.
Okay, and you can do any other announcements in the show as well.
Yeah, I should probably announce the Spreadshirt site. Let me pull that up.
Any updates on Cosmo Academy?
No. We're waiting on paperwork at the moment to see if we can do some exciting awesomeness.
Okay.
Vague. I'm going to go for vague.
Stand by for exciting awesomeness. Awesome. Excitingness. Okay. All right, I'm going to get my intro going. Oh, yeah, and you can also talk to us if you want. You can use the Q&A app. Go ahead and use that app. Use the crap out of that app. So right now it says Fraser Cain is interacting with the audience, or at Astronomy Cast now is interacting with the audience, and so it'll say, so you click that, and then you get the video, and then you get a cool QA thing. Just one note, I try to pull the questions from there, so if you want to just like a chit chat, the best place to do that is just on the event page where the Hangout is, or on the Twitters, or just talk to yourself. So, are you ready?
I think so.
Okay. I got my intro ready to go. I've got my newly installed Audacity. I hope this works.
And people are active in the question and answers already. Okay, I'm going to go ahead and press record. I've clicked record. It's recording, and all the settings are even correct. Hi,
I
Preston.
have I have done the same. Hi, Preston. And now I gotta sneeze. All right, I'll tough through it. We'll edit that out. We'll fix it in post. All
Sorry,
right.
Preston.
Okay, here we go. Astronomy Cast, episode 360. Jocelyn Bell Burnell. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good, good. I'm feeling a little sniffly today, so I reserve the right to sneeze once or twice during the recording, but I know Preston will remove that, and so it'll never happen. You've got a bit of an announcement about our about some things people can wear.
I do. So we've had a lot of people saying, hey, we know Astronomy Cast t-shirts exist. Can we get some? And the answer is yes. If you go over to astrogear.spreadshirt.com, we have mugs, we have t-shirts, and you can customize them. We have boy cut and girl cut. You can pick out the colors that you'd like them to be in. And proceeds from buying these shirts goes to support keeping all of our programs running. Basically, you're paying for the servers if you buy mugs and t-shirts and sweatshirts. So please buy mugs and t-shirts and please buy mugs and t-shirts and sweatshirts at astrogear.spreadshirt.com.
They make wonderful Festivus gifts.
And new to miss.
New to miss?
Right. So Newton was born on Christmas Day.
Oh, that's right. Oh, that's great. I'm totally celebrating Newton Miss.
So we acknowledge all of the birthdays here on
That's awesome.
December 25th.
All right, let's get rolling. So Jocelyn Bell Burnell is an Irish astronomer, best known for being part of the team that discovered pulsars. And I love this story, which I hope we'll get at it. And the following controversy when she was excluded from the Nobel Prize winning team. Oh, this is a theme, huh?
Yeah, themes sometimes happen. I mean, our original theme was awesome modern astronomers, and I went down the list of awesome women who are still alive who forced textbooks to get rewritten or led to the things that we all learned the names of. And it just happened that a lot of these women did things that, had they been a guy, probably would have gotten them a Nobel Prize, but not a guy. So
Nobel Prize, please. Okay, well let's start with I think we've done this sort of before, but let's start with the big discovery that Jocelyn Bell really helped with, and then we'll kind of go back around and actually talk about her history and what she's been working on. And that was pulsars.
Right. So she was a graduate student in the 1960s. And while a student at Cambridge, she worked on building a large radio facility to look at the sky in literally a different color, in this case radio light instead of optical light. And when she started getting her data, there was this, what in a very British way they refer to as scruff in the signal.
Isn't that when they were looking for like bird poop back in the cosmic microwave background? Yeah, no, I understand, but it's that same thing. You know, I think the Brits would have called that scruff.
Probably. Yeah. So in her data of this one particular place in the sky, and that's always a hint, is it's that one place in the sky. There was this bit of scruff, and she would take all the data she could on this object, and it just seemed to be ticking like a clock once a second. And she basically had to chase down her advisor and say, no, look, really, this is real. And he didn't want to believe her originally, and then when he did believe her, they, of course, published the results, and then he would do big conferences, and she'd end up having to speak, but he wasn't the one inviting her. And it just kind of went on like that for a good long time. And it was this awesome discovery that at the end of the day, they had to figure out, well, what could possibly be making a ticking noise, or in this case, a ticking light signal that got translated into noise once a second. And the only answer that made sense,
Aliens.
well, they did call it the little green men at one
point. I know.
But aliens aside, neutron stars are one of the few objects out there capable of holding themselves together while rotating that rapidly. And through a variety of different types of observations, it was narrowed down to, by golly, this is a neutron star rotating. And eventually it was figured out it has a magnetic field that isn't aligned with the rotation axis of the star, sort of like the Earth's magnetic field isn't aligned with the rotation axis of the planet. And as that magnetic pole goes through our field of view, we get this burst of radio signal. And she's the one who found this, discovered this, forced someone to look at the results and go, here is this awesomeness. It's not scruff in the data.
There's something out there pulsing every, and I've got the number here. You ready for this?
Yeah.
1.33730288331 seconds. In other words, every 1.33 blah 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 seconds, we get a radar pulse, like a lighthouse flashing us, which must have been terrifying to sort of, or amazing, astonishing to see an object with that kind of regularity out there in the cosmos.
Luckily, we see the signal and then figure out what it is. So I think if we saw a star rotating at 1,000 times a second at a distance that wasn't very far away, it might start as terrifying. Luckily, we're like, what is this? And then only after a while do we realize that some object really far away. And when it's really far away and takes you a while to figure out, it's just awesome. You skip straight to the awesome, bypass the terrifying.
Yeah, but this is a slow spinning.
Right.
LGM1, or PSR J1921 plus 2153, is only turns a little over once a second, while there are millisecond pulsars out there.
Right. So there are objects that are greater in mass than the sun, smaller in diameter than, like Manhattan, basically, that are rotating 1,000 times a second.
Right, and blasting out radio waves.
Right, as one does.
As one does, yeah. So then, I guess, once they had discovered this object, what was sort of the thought process? What do you think was going on, apart from it being scruff? I mean, how did they make that connection between it being a neutron star and what they were seeing in the data?
Well, you do look at things in multiple wavelengths and start to figure out, okay, so what could be causing this? What is in that area? Are there more of them? More of them were found. And you just put the pieces together one by one and realize there's only one thing this could be. And really, if you think about any other object rotating that quickly, it would fling its surface off if it tried. So you can't get white dwarfs going that fast. You certainly couldn't get the sun going that fast. You need something that is very tightly bound together, and a black hole can't exactly give off light every 1,000th of a second because black hole. And so when you eliminate the white dwarf and recognize that black holes don't emit light, that leaves you just with a neutron star.
And what is the process? And we've done a whole show on pulsars and neutron stars, so I don't want to give the long versions, but what gets you that rapidly rotating thing that's blasting out the radiation on a regular basis?
So as we talked about a few episodes back, there's this horrific thing called conservation of angular momentum. And the side effect of this is that when ice skaters or stars, physics doesn't care which you are, when they go from having their mass spread out over a large volume, the ice skater with her arms straight out, to having their mass spread out over a smaller volume, this is the ice skater bringing her arms in, You're going to
Yep.
speed up. And when you go from being a giant star to this residual leftover bit at the end of probably a supernova explosion, what's left of you has to take whatever angular momentum that giant star had as it slowly rotated its giant self about its axis. And when you go from perhaps being the size of Jupiter's orbit or larger down to Manhattan, um, you spin up a lot.
Hmm.
And it's just that conservation of angular momentum coupled with supernova explosion.
So the conservation of angular momentum gets you the rotating speed, and the beam. It's not actually that it's pulsing and flashing like this. It's that there's a beam coming out of these things.
Right, and that's the magnetic field. Its physics is very similar to how we get the beams coming out of the ends of quasars. You have magnetic fields that just like to shoot things out their poles in terms of you have rotation about an axis. In this case, the dynamo, for whatever reason, isn't completely aligned with the rotation axis, and that leads to a north and south pole that repels charged particles. And as those particles move, they undergo all sorts of different physics that leads to changes in energy levels that leads to release of, well, radio waves.
All right, let's go back to Jocelyn Bell then. So that was her discovery. Let's kind of go back and sort of continue on her story. So she discovered this amazing thing. I guess it had been the neutron stars had been theorized, but people hadn't seen
well, we hadn't seen pulsars yet.
We haven't seen the pulsars yet. Okay.
And so
how is this received?
Well, so neutron stars exist in binary systems. We knew they existed. It was just this idea of rotating with a misaligned magnetic field that was entirely new. That was something that we still are like, wow, okay, that's kind of And so that was back in 1967 that they made these observations, worked on figuring things out, and she went on, finished her degree up, went on to work at the University of Southampton from 1968 to 73, went to the University College London, was there 74 to 82. At that point, she went to Royal Observatory in Edinburgh from 82 to 91. And then eventually she landed at the Open University from 91 to 2001. And she was an amazing educator. She was someone who spent a lot of time in the classroom, spent a lot of time with students. She worked on projects at Greenwich Royal Observatory and their planetarium, serving on their board. She worked as a tutor, a consultant, all sorts of different tasks. Eventually, once she pretty much retired from active teaching, she went on to be a visiting professor at the University of Oxford, where she was again focusing on mentoring and continuing research. But what was interesting is all of this was kind of flavored with the, yes, I did this awesome thing when I was young. I was a student. Yes, my advisor got the Nobel Prize for it, and I did not. But I was the student, and if you're going to yell at faculty members when they try and blame their student for their failures, you should probably actually also give them the prize when their students do something awesome. And that was just a very interesting way of saying, look, just chill, in a very politically correct way that really, I think, has caused a lot of people to respect her across decades. And it also led to her eventually becoming one of only 2 women in the UK to be senior professors. So she had that tenure dream that so many of us wish for, and she managed to be one of the 2 women in an entire modern Western nation that succeeded.
That's an interesting response to this, because she really was snubbed. I mean, it was the 74 Nobel Prize in Physics, and a lot of fairly influential astronomers were were pretty outraged that she wasn't part of the winning team. And I never understand that, because I mean, they can, whatever's the team that wins the Nobel Prize, they can kind of share it among a bunch of people.
Three
Right?
people.
Up to three? Okay.
And
there was
Fred Hoyle was actually so incensed and raised such a stink that it's considered that the stink he raised about her not getting to it led to him not getting it in '84. So you had people who were throwing such a stink that they put their own careers in political jeopardy. And that doesn't happen very often.
Right, and the gist of her response was, I was a grad student, part of a team. The team was created by, was it Hamish? And yeah, and we made this discovery. But if you're going to blame him when everything goes sideways, you should also reward him when everything goes well, for being the team leader, which is a pretty classy way to sort of respond to being snubbed and not getting your Nobel Prize.
Right. And that, I think, also reflects a lot on her upbringing, a lot on her personality. She is someone who's always been deeply involved in the Quaker Church. She was raised in Northern Ireland, where she attended a boarding school. Actually, she had a really interesting childhood, because she was attending the local, they say college, but it's actually the local girls' school, Lurgan College. And when she was about 11 years old, she took her exams to figure out what was the rest of her fate for her education, and failed. And normally that means that you go on to study for a trade. It means that you don't go on to college. And the school that she'd been going up until that point wasn't even one that normally taught sciences. They instead put emphasis on things like cooking and womanly skills, learning to sew. And a bunch of parents did throw a fit. They did get science into the curriculum, but she still failed her national exams. And her family went on to send her to a private girls' Quaker boarding school. So she went on to Mount School in York, and it was there that she finally started to do well in science. And it wasn't that she hadn't grown up surrounded by science. Her dad was the architect of the Armagh Planetarium, and she'd been reading his science books, but you need the passion and you need the education when it comes to exams. And her parents made sure that she got all the opportunities that she deserved.
It was a very sort of high level of specialization at a very early age, kind of going straight into physics and progressing along that when she had kind of failed the more general test. It's pretty interesting.
And it really speaks to how different education is in other nations. Here she was at 11, and they're telling her, no, sweetie, you need to just go study trade. You're not smart enough to do this professional work.
Maybe a hairdresser.
Right, exactly. Yeah. And her family was like, nope. And sending your child away is a difficult task in a lot of cases, and they recognized it was what was needed.
So we've talked a bit about her her initial discovery. What were some other kinds of research that she was involved in?
So I spent quite some time trying very hard to find how many papers that she's done, that like we did last week with Margaret Geller. And I ran into this rather horrifying problem that there are a lot of J. Burnells. There are a lot of J. Bells, because she's published under both names. And so trying to trace her research across all the decades has been somewhat challenging, you might say. She has continued to work on pulsars throughout her life, looking at them in the optical, looking at them in the radio, looking for the awesome ones, looking for the weird ones. But chasing down any other research she might have done left me sort of confused in ADS, because initials and last names that overlap make things difficult at times.
So you don't have any more additional information than this one?
So the best I can say is she's someone that continued to do a lot of work in pulsars, and she's someone that is modest to the point that I couldn't find a website bragging about all the other stuff she's done over the years. And that pleased me and made preparing difficult. So here you have this woman who's now in her 70s who is mostly retired. She stepped away from a lot of her board positions. She's still plugging away at Oxford. I got to see her give a talk on pulsars there. And if you look up her initials and her last name in pulsars, you get a ton of papers. But there's no website that she's written that says, and I did this, and I did this, and here's my CV, and you can see all of the awards I've gotten. A lot of people have that, and she didn't feel the need to have that anywhere, and that's kind of cool.
Someone should help her with her social media profile.
It sort of falls into the category of grandma needing a social media profile. In this case, she's one of those senior scientists who's probably produced multiple generations of academic children at this point. And I think she's doing good.
Now, had you met her? Have you seen her speak?
Yeah. I've seen her speak, and I've actually got to sit down and have conversations with her. She's the type of person that she's going to be blunt. She's going to, if you say something stupid, she's going to point it out to you in a very British way. But she's also going to listen to the junior scientists in the room, and she's going to look for ways to open doors and help them out. And that dichotomy of not tolerating the fool while at the same time looking to raise up the people who need opportunities is an awesome thing. There's too many people out there that will just let you say stupid things and at the same time don't work to help other people out. And she's not that person. She's just forthright and does a good job and was very tolerant of my students who, being Midwesterners, Oxford is as far away from Southern Illinois University, Edwardsville, as you can get. And she sort of smiled and was British through all of the odd things that came out of their mouths occasionally.
Right. Oh, I'm sure I would have been hilarious to talk to her. But I know you have a bunch of friends at Oxford, right? What's the sort of astrophysics program like there?
It's one of the big ones out there. It's a large department in terms of being physics and astronomy combined. One of my dissertation committee members came from there. I worked with people while I was there on the Texas-Oxford survey as a graduate student. It's the type of department like Harvard or Arizona where if you're an astronomer, you can't go through your career without at some point working with people from these places. And they do a lot of work, and they produce a lot of humans, and it's just a big astronomy center.
Yeah, we're endlessly reporting on it with Universe Today on the research that they're doing. So cool. Okay, well, thanks a lot, Pamela.
My pleasure.
All right, let's stop that.
I tried to pause my browser instead of my audio. Okay.
Don't. Okay. Save it. Why am I wincing? Because I just don't trust
I don't know. You really don't.
I really should I? No. So
I don't know. There are some things I know better than to respond to. Should you trust computers? Unknown.
Unknown.
Answer
no, we love our computer overlords.
There's a difference between love and trust.
All right.
I love my dog. I do not trust my dog if there is a steak on the coffee table.
All right, I have saved my my recording, so I will move it over to the Dropbox. Let us take a look at the questions. All right. Cecil Morgan says, congratulations on the New Horizons Hangout. It's quite a lineup. Are you trying to upstage Tony Darnell's series hangout on Thursday? Tony's doing a series hangout on Thursday?
Yeah, he is.
Oh, that's great. Oh,
yeah,
everybody, go watch Tony's.
Team.
Yeah, everybody go watch Tony's episode on Thursday. That's awesome. Okay. Guido Bieber notes that the Nobel Prize is half politics, therefore somewhat overrated.
It's more than half.
Half, three-quarters. You know, yeah. You could have bought a Nobel Prize just for $4 million this week.
Yeah, I don't feel like giving money to political views occasionally.
Wait. Okay, here's one. This comes from Ryan Schmitz. My coworkers and I are wondering how far away we'd have to be for the sun to look like a regular star, and where would that location put us in relation to the planets in our solar system? So,
It really looks like a star from Neptune or Pluto.
Right, it looks like just a bright star from Neptune or Pluto. Yeah. And then where would that put you in location of the rest of the planet? So Neptune or Pluto. It would be cool if I don't know if New Horizons is gonna do this. I guess I should ask Alan if they'd be kind enough to turn the spacecraft around and take a portrait of the sun from the orbit of Pluto.
Well, they're not going to orbit Pluto. They're flying.
From the orbit of Pluto, not orbiting Pluto. From the distance of Pluto. Yeah. Yeah, I know it's a flyby. Noel Ruppenthal asks, is it possible to have an elliptical orbit that goes in and out of the event horizon of a black hole?
No.
No, that is what the event horizon is the place where you have to be going faster than light speed to get out again. So.
And as far as we know, tachyons do not exist except in the Star Trek universe.
Except in Star Trek, yeah. Get the tachyons online. So no, that's the problem. That's the definition of the event horizon. That even light is going in at that point. Okay. Unless it's the movie Interstellar.
I did go see that.
Yeah? Now Kip Thorne stands by the physics in that movie.
I'm fine with the physics up until they start making shit up because he's inside the black hole.
Okay. Hey,
and that's all I'm going to say.
Don't spoil it. Thomas Tredeker asks, what is the speed range of pulsars, slowest to fastest? All right, let me look this up. Allow me to Google that for you.
Yes, fastest will be milliseconds, slowest will be many seconds.
Pulsar. Hold on. 716 times. So above 1,000 rotations per second, they lose energy by gravitational radiation faster than accretion process will speed them up. 716 times a second is the fastest spinning pulsar, and that is pretty much at the very limits of how fast they can go. There you go. 1,500 is sort of the theoretical. That's when they break apart. So I hope that answers your question. Slowest, you said just like seconds, minutes?
Yeah. I don't think minutes. I'm not sure we would detect it at that rate, actually.
You would, yeah, but I guess the question is, would the magnetic field die down as it slows down its rotation speed?
Well, so yes, but it would still have the magnetic field. But would we notice it?
Yeah. Sorry, I'm just looking this up. Yeah.
We're taking turns Googling your answers because they require proper numbers.
Yeah, let me Google that for you.
1,062 seconds is the slowest one that I just found.
Okay, cool. All right, let's move on. There you go, 1,062 seconds. So minutes. Cecil Morgan notes, the biggest misaccreditation was Watson Crick getting Nobel and writing a book on DNA without mentioning Rosalind Franklin. Yes, that was pretty egregious.
Which is part of my desire not to, Yeah.
Okay.
I know I only learned about Watson and Cricket in my textbooks.
Will Adoni says that when she talks about it, I guess Jocelyn Bell Burnell, says she reconciled with the fact that graduate students were not eligible for the Nobel, but even so, she was robbed. She was robbed, he says.
Well, and graduate students do get the Nobel Prize. I mean, look at Adam Rees. And he's not the first one. One of the ones for the pulsar binaries, not pulsar, black hole binary stars showing gravitational energy loss. There are several examples looking down through history of male graduate students getting the Nobel Prize along with their advisors.
Leonard Lindstrom says, does the rotation rate of a pulsar affect the radio frequency that it broadcasts at?
I don't think so. It would Doppler shift it.
But I guess
but we wouldn't see that.
Right, but the radio frequency is a result of the interactions of the magnetic field with its environment, right?
Yes.
And the wavelength of the radio waves that we're getting are generated at a specific. I'm making stuff up here.
No, you're right. Okay. You're right. It has to do with the way the electrons give off light as they interact.
Noel Rupendahl says, it just sort of has a follow-up, is the event horizon where escape velocity is the speed of light, or where you just have to be moving faster than light to cross it?
It's defined as the point where the escape velocity equals the speed of light.
Right, so you get closer to the black hole, you get closer to the black hole, so here's your event horizon, you go down closer, the escape velocity just gets higher and higher and higher. You've got to go double the speed of light, triple the speed of light, 1,000,000 times the speed of light. But it doesn't matter because nothing goes faster than light. So it's all just, at that point, it's just
you're
worse
not
and worse
leaving.
And worse. Yeah. You're dead, and then you're deader, and then you're even deader.
Well, when you cross the event horizon, you're not necessarily dead. You just aren't escaping anymore.
Yeah, you're never coming back out again. Yeah. Hugo Burnham asks, are all pulsars neutron stars, and are all neutron stars pulsars? No.
So all pulsars are neutron stars because you need that density to be able to rotate that quickly. But you can have neutron stars that, through whatever variety of how their host star exploded and everything else, these suckers do slow down. They're just happily sitting there being their neutron star selves and not pulsating. Or being pulsars. Pulsating stars and pulsars are not the same thing.
And that the speed of the pulsar tells you its age.
Yes, that's true.
Right. That the faster they are, the closer they were to that
supernova event.
Yeah. So the supernova went off, and then you get the super millisecond pulsar, and then it slows down as it's literally converting rotational energy out this radiation. It's amazing. And I got a question for you then. If a star was spinning super rapidly and it turned into a neutron star and it was going faster than 1,500 times per second, would it then just tear itself apart and there'd be no pulsar? But it wouldn't be a black hole? Yeah.
It should. And there's got to be some weird physics involved. So, for instance, the really slow spinning one that I looked up, I'm looking at an article on space.com to get full attribution. And it's talking about SXP1062, which is a 40,000-year-old pulsar, but it's rotating every 1,000+ seconds. So there's something screwy that goes on that can slow them down. So you can have them slowed down, but their rotation rate gives the minimum age of, they can be slowed down. So if you have something that's going 1,000,000 times a second, it has to have formed recently. So you get at limits to their age, but the stars can get artificially slowed down so things can appear to be older than they actually are.
Right.
So you're getting a lower limit.
Right, and the rotational speed of the star just depends on the total amount of the conservation of momentum from when it was a big cloud in space. And so the sun, for example, takes a month to spin once on its axis, but there are stars out there that are like footballs. They're already spinning once a day,
The
multiple times a
fancy word
day.
for that is oblate
Oblate
sphere.
spheroid.
And they're not really footballs because that would imply that they were being stretched in the opposite direction of what they're being stretched.
Right. They're oblate spheroids.
They're oblate spheres. But and I said that wrong. It's the rotation rate gives us the upper limit on how old these systems are, because the stars get slowed down, so the system can appear to be older than it actually is.
Tom Nathy asks, and I don't know if you know the answer to this one, about how often would an average pulsar have crustal deformations, aka star quakes?
No idea.
Yeah.
This is one of those things that I think we're still figuring out. There are amazing starquakes periodically that lead to reconfiguring of the magnetic field around the star. Giant X-ray and gamma ray blasts of energy can come from these. There's a huge one back in 2004 that actually managed to get detected as it passed sideways through the walls of satellites. Did bad things to a few satellites that had to get reset. Amazing amounts of energy can come from starquakes.
Okay, so was there any comments on Twitter? I don't see anything here.
No,
You
I haven't seen
mentioned
anything.
to somebody, Best of Astronomy Cast.
Oh, right. So Jason Donker was using time hop and found a quote that must be you.
That was me, yeah.
Yeah, of most parents have had that uncomfortable conversation with their children at some point. Mommy, Daddy, where do baby stars come from? You hem and haw, mumble a few words about angular momentum and primordial hydrogen, and then cleverly change the subject. So I was deeply amused by this screen capture he shared, and then the last word is Astronomy Cast. I'm like, oh, that came from us. That's cool. I did not say that.
Right. Yeah, that sounds like something I would write.
Yeah.
Okay, cool. Let me see if there's any more comments on the event page, and then we will wrap this up. Guido Bibra provided a link. So episode 158, we did pulsars 5 years ago, and wonders if an update is necessary.
Not really.
Not. That is like the biggest. I gotta say, that is one of the biggest surprises to me. I was certain, with the amount of stories that I'm familiar with Universe Today, how many different. I figured we have update stuff all the time, but we don't. It's amazing how the fundamentals, the big picture stories, have remained the same for decades.
Yes.
But we get these tiny little incremental, improvements, but they're still 7 years, 8 years doing this. There haven't been a lot of gigantic, brand new pieces of information that we weren't aware of. Just further refinements on what dark matter isn't,
Right.
Things like that. So, I think that's it. So let's just wrap this up. Yeah.
That sounds
anyway,
good.
we have some further work to do. We have an advertisement to record.
So sponsorship message. Well, yeah, no, this one's an advertisement.
Yeah.
So we are looking for sponsors. So if any of you out there who are still hanging on, who are likely to be the types of people that are going to invest in going to someone you know who's a small business owner or your own company and saying, hey, I know these people. They could use a sponsor. We're always looking for sponsors.
It's Christmas time. We've got tens of thousands of listeners. It's a very, the holiday season. People are buying stuff for Newton Miss. Sorry, and so just go ahead and reach out to Pamela, or also you can do advertising through Wizard, which is our Libsyn, yeah, which is the hosting provider that we do. So. Cool. All right. Well, thank you very much, Pamela. Thanks, everyone, for watching. We really appreciate it. And we will see you all on Wednesday for the New Horizons conversation. Also Wednesday, Learning Space.
Yes.
Are you guys doing Lunar X Prize this week?
No, that's next week.
Next week? Okay. And then Thursday, you should go watch Tony Darnell talking to the series folks. That's really exciting. That's going to be on par, I think, with like Rosetta. So that's super exciting because they're going to orbit an icy asteroid.
Yes.
And then Friday we got the weekly Space Hangout. So it's going to be an action-packed week. We just can't
Sounds
stop making shows.
science.
Science. All right. Thanks, Pamela. See you everybody.